Assalamu alaikum students, I am Nayab Idrees and today we're going to start the second lecture of the same chapter, data representation, that I posted last week. So we're going to start in the name of Allah, the most merciful and the most compassionate. So last time I told you about the number system, like the binary number systems and the denary and the hexadecimal. Today we're going to do representation of text, sound, and images. So first we're going to talk about representation of sounds. Let's start. Sound travels in the form of waves caused by vibrations in the air. So first we're saying that sound is caused by vibrations, and those vibrations travel in waves. You see these waves in these two diagrams, that sound always travels in waves. It is caused by vibrations. Each sound wave has a frequency, amplitude, and wavelength. These three terms are related to sound. That amplitude specifies the loudness of a sound. So a sound is loud or unclear or small. So the amplitude, the amplitude specifies the loudness and how loud it is. Is it loud or is it low? So amplitude specifies that. So a sound is analog and it is not an digital data, it is an analog data. Computers can't understand it. So obviously computers only understand digital data. They don't understand analog data. So the sound are sampled by an analog to digital converter. This is a device called the ADC, or the analog to digital converter, which converts the analog data to the digital data, which the computer can understand. This way the sound waves are sampled at regular intervals. The amplitude of the sound is not measured precisely, but closed values are stored. So as you can say that the computer can't understand the digital data. So first of all, the ADC, or the analog to digital converter, converts the sound into digital data. This way, when we put them in regular time intervals, we measure the amplitude of the sound, like how loud the sound is. And then by measuring that, we store the data in the binary language, like in the computer. So the number of bits per sample is known as sampling resolution, or bit depth. So when we sample it like in time intervals, the number of bits for, like if we take one sample and it is stored, the number of bits that are used to store that one sample is called its sampling resolution, or bit depth. That how many bits that it takes for one sample to store. Sampling rate is the number of sound samples taken per second. If we do sampling and in a second we take three samples, that means that is sampling rate is 3 Hz. That this is measured in hertz or Hz. The symbol is Hz. This is measured in hertz. So in 1 second, if there are like three sampled sounds, this means that the rate of sampling, or the sampling rate, is 3 hertz. First, the amplitude of the sound is determined at set time intervals. Then the given approximate representations are stored in the form of binary digits. So how is it even sampled? First of all, it is set in time intervals, and then the amplitude of the sound is stored in in form of binary digits, because the computer stores in binary digits. You can see that in this diagram that how the time intervals are taken. So there's like a time interval over here in one part, and this is like, this thing is the amplitude, the how loud the sound is, and over here you can see this is a lot louder than the upper one because going so up. So that means that it is, the amplitude is big, and then the value of the binary digits will be big too. So if we use higher sampling rate or larger resolution, the quality of the sound represented would be good. So if in 1 second we use like a lot of samples or a larger resolution, like we use more bits in representing a sound amplitude, the quality will be a lot better than a low sampling rate or the resolution, because we're using a lot of bits and a lot of seconds. So that means that the quality will be good. It won't be like it won't be like not it won't be bad. The quality will be very good. But the higher the resolution, the greater the file size. Obviously, when there are more bits, like there's more bit depth, like there's more, we use more bits to represent a sampling amplitude. That means that there will be a greater file size because of the more bits and more sampling rate. Representation of images. First, we talked about the representation of sounds, the sampling rate, the bit depth, or the resolution. Now we're going to talk about representation of images. Images or bitmap images, they're also called bitmap images, are made up of pixels. Pixels are the smallest unit of a picture. As you can see in the diagram, the smallest unit, you can see these squares are the pixels. Like they're the smallest unit of the picture. So in the diagram, you can see there are like a lot of pixels making this picture. You can see this picture. This is a pixel. This is a pixel. The smallest unit of the picture is called a pixel. Those pixels can be represented as binary numbers. A black and white image only requires 1 bit per pixel. So in a black or white images, like the movies that were like ancient movies in which they were black and white, in those videos or movies, 1 pixel would only need, or a picture, like in images, a black and white images would only take 1 bit per pixel because it's only black or white. Either it's 1, either it's 0. If it's 1, it's white, and if it's 0, it's black. So 1 pixel would only take 1 bit per pixel. If each pixel is represented by two bits, then each pixel can be one of the 4 colors corresponding to 0, 0, 0, 1, 10, and 11. So if we use 2 bits for 1 pixel, means that there are 4 colors that we can choose from. If the bit is 0, 0, there'll be some other color. 0, 1, some other, then 10, 11 means other colors. If each pixel is represented by 3 bits, it can be one of the 8 colors corresponding to 0, 0, 0, 0, 0, 1, 0, 10, 0, 11, 100, 101, 110, and 111. So the more the pixels we use for, the more the bits we use for a pixel, the more the colors we can choose from. The number, like if there are 3 bits we use for 1 pixel, it can be one of these colors. If we use 2 bits for 1 pixel, it can be one of the 4 colors. The the number of bits used to represent each color is just color depth. So if we're using a pixel of yellow color, the number of bits which will be used in that color of the pixel color, that is color depth. Representation of images again. So image resolution refers to the number of pixels that make up the image. For example, an image could have 4,996 multiplied 3,072 pixels, 12,582,912 pixels in total. That means that the image resolution is how many pixels we even use in a picture. The more pixels we use, the more higher the quality. As in we can use more pixels, which will be a better quality. That has been described over here. As you can see the above diagram, the image with the low resolution has scattered and visible pixels because it has less pixels. The second one has more pixels than the others, and the last one is the clearest picture because it has more pixels than the others to present the picture. So in this diagram, as it is described over here, this picture has less pixels. That means that the resolution won't be that good because when the pixels are low, there'll be low number of pixels to represent that image. In the second image, there are like a little more pixels. There in the second image over here, there's like a little more pixels than this picture, so it is a little like better than this picture. But in the third image, they're like higher resolution because there are more pixels. They're like the highest number of pixels, which can make an image very clear. Low spatial resolution, medium spatial resolution, and higher spatial resolution. But there's a drawback of using high resolution images is that it increases the file size with impacts to memory. So if we use like a higher resolution file, an image, it will increase the file size because the more the pixels, the more the file size. When it increases the file size, this will impact the memory. So that means that we can store a lot of high spatial resolution images in the memory. Data storage and file compression. Measurement of data storage. The bit is the basic unit of all computing memory storage terms. Each bit makes 1 byte, which is the smallest unit of memory in the computer. So bit is the smallest unit that we can use in the memory, and 8 bits makes 1 byte, which means the byte is the smallest unit of memory in the computer. So there are some terms for the memory measurement. So then the 1 kilobyte equals to 1024 bytes. Okay, 1 megabyte equals to a number to 1048,576 bytes. 1 gigabyte, 1 GB, you also know about that. That makes 1,073,741,824 bytes. Like just like this, they're like 1 terabyte, 1 petabyte, and 1 exabyte. These are all the terms of the memory measurement that containing this much bigger number of bytes. Then data compression. As sometimes sound and image files can be very large and take a lot of memory, they need to be compressed, basically reducing the file size. So actually, when there are like a lot of if we have a lot of image and sound files and they are so big that we can't store them in the memory, or we can't stream them, or we can't share them, so we have to compress the file so it can be streamed, shared, or stored. So it helps us to reduce the time taken to stream or share these files. Just like I said, that when we compress a file, we can share it easily, we can store it easily, we can stream it easily. Compressing a file also helps to reduce costs when sharing and storing in cloud storage. So sometimes in some cloud storages, we have to pay real money to store our data. So if you compress a file, there'll be less cost of this, because if the bigger the file size, the more the money. So when compressing the file, it reduces the file size, which means that there'll be low cost. The download or upload process uses a network of bandwidth, which is the maximum rate of data transfer on the internet measured in bits per second. If a compressed file is uploaded or downloaded, this will result in faster data transfer. So when we upload or download some file, a sound file, or an image file, the used network is called bandwidth, which is the maximum rate of data transfer. Internet measured in bits per second, like how many bits are transferred in a second, like how many bits are downloaded in a second, or how many bits are uploaded in a second. So if there's like a compressed file, there'd be less data in it. So that would take less time to transfer the file, which will use less bandwidth, would be very advantageous. So then it's file compression. Again, file compression. So there are like two types of file compression, called the lossy file compression and the lossless file compression. You can even tell by the name that in lossy file compression, we may lose some data, but in lossless file compression, we can't lose data. So in the lossy file compression, in this technique, when a file is compressed, some of the unnecessary data is deleted, but the file can't be reconstructed once it has been compressed. So in lossy file compression, when you compress a file, some of the unnecessary data that you don't need is deleted to compress it. But we can't take the data back to reconstruct the same file that we constructed. That is like a lossy, that we can't restore the data we have lost. So what happens is that an image file may lose pixels of resolution. So when we compress an image file, it may lose some pixels, which would definitely lower its resolution. In an audio file, the sampling rate or resolution may lower. In an audio file, if we compress it, then maybe that the sampling rate lowers and then the resolution lowers, which makes the sound less clear. The quality of both image or audio would be lost, like it'd be a little lower in lossy file compression. In lossless file compression, in this, all the compressed file data can be reconstructed, means that no data is lost. We can reconstruct it back. This technique is used when compressing important files, like transferring a large complex spreadsheet where no data should be lost. So we always use this file compression so we can't lose any data. If we use the lossy file compression, we can lose some data. When we're transferring office files like spreadsheets, Word, PowerPoint, anything that is very important and we don't want to lose data from it, we use a lossless file compression. Thank you guys. Today was this chapter, and this chapter has been ended, and I'm inshallah gonna post the next lecture next week. Thank you for watching, and if you find my lecture helpful, please like the video and subscribe to my channel and share this video to all your friends and family.